Okay, so here is definition 1. Now, suppose that V and W are vector spaces of n and m dimension, respectively, with bases B and D, respectively, and that H is a linear map from V to W if the representation with respect to D of H of beta 1 equals this, all the way through the representation with respect to D of H of beta n equals this, right? So we're going to have these column vectors. If that's true, then the representation with respect to B and D, B comma D of H, the mapping, is given by this matrix. Basically, we're joining the column vectors into a matrix, an n by m, or an m by n matrix. Okay, because there's m rows and n columns. This is called the matrix representation of H with respect to B comma D. Okay? That is the definition. Now, in that matrix, the number of columns n is the dimension of the map's domain, while the number of rows m is the dimension of the codomain. And as with the notation for representation of a vector, the representation with respect to B comma D notation here is not standard. Okay, the most common alternative is this. We've seen this before. Okay, the most common one is this. Okay, so again, if you look at other textbooks, that's going to be the most common way of denoting the matrix representation. Now, also keep in mind, we use lowercase letters for a map, uppercase for the matrix. The lowercase, again, for the entries of the matrix. Okay, so for the map H, the matrix representing it is capital H, right? So this matrix here, we would denote capital H, but the entries themselves are with lowercase h's. And that's it. So again, we're talking about with entries Hij. So I is the row, J is the column. So row is always first, Ij. Okay.